All right, everybody, so today we are going to be looking at checking for balance in systems of equations. So we're just making sure that each system is balanced like our coat hangers were in class yesterday. So each step we have to double check. Remember, x is our first term and y is our second term. So as we are working our way through these, we just have to remember those concepts as we plug in. So the first one for 0, 3, x, y, we want to plug into our first equation. So we have 0 for x, we have 3 for y, so 0 minus 3, which gives us negative 3. We're trying to see, is that equal to 3? Well, negative 3 is not the same thing as 3, so we know that that does not work for our first one. So we know right away, boom, we do not see balance in both equations. Now, it could be balanced on the second one, but that doesn't matter because it's not balanced on the first, so it cannot be a solution to the system. For number 2, 3, 0, we can take a look here. So again, plugging into our first equation, and we're checking for balance. So 3 minus 0, so 3, is that equal to 3? Yes. That is not good enough to say for sure. We do have to take a look at both equations to make sure that both are balanced. And unfortunately, it looks like we do not see balance in the second equation, so we know that number 2 is not going to work for us. Lastly here, negative 1, negative 4. So negative 1 minus negative 4, these are two negative signs come together to be plus, so that actually will be 3 equals 3. So that does work for our first equation. For our second equation, we do need to still plug this in. We're going to have negative 7 plus 4. In this case, again, two negatives come together to be a positive. And this does, in fact, equal negative 3. So that does satisfy it for both. So our only solution that works for both is C. It's possible that all three will not work, so don't just assume because the first two don't work that the next one will. Going to follow the same process for our next one here. So our negative 2, 1 for our first one. Plug into our first equation. And we're going to see, does this equal 24? In this case, we're going to see negative 24 is what we get, so that is not the same. So the first one does not work. On to number 2. Look at 12 here. Two negatives do make a positive for our next one here. 24 does equal 24, so we're happy with that. It's our first equation, but we do need to check number 2. So again, plugging in for x and y. We do have 4 equals 4, so that is good. Answer choice E works, but we're not done because we could have multiple that work, so we always want to make sure we are double checking. So we could have negative 2, negative 1. We're trying to see, does this equal to 24? Running out of space on the side. So negative 12, positive 12, does that equal 24? And what we're going to see here is 0 does not equal 24, so we can confidently eliminate answer choice F. So again, a little bit tedious here plugging in. Be careful with those negative signs. Use parentheses when you plug in, but as long as you do it consistently, you will be in great shape for solving and identifying the correct solution that balances both equations. Lastly here, where are we ending up? Is where we intersect. So common solution is also known as the intersection point. And in this case, we're going to go 2 to the right, and we are going to go 1 down. So remember, for these ordered pairs, x is left and right, and y is up and down. So again, positive is up, negative is down, positive is right, and negative is left. So 2 to the right, 1 down gets our intersection point, our common solution. That's all for today. Best of luck plugging these in, and again, make sure to take your time, and as long as you do that,